object. If a body of volume V is immersed wholly, that is fully, in a fluid of density rho, then the volume of the fluid displaced by the body is also V, and the mass of the fluid displaced by the body will be rho into V. So, the buoyant force of the body is equal to the density of the fluid into displacement of volume of the fluid, that can be written as rho Vg. So, this is the experimental verification of the Archimedes principle and the two conclusions. So, some applications of Archimedes principle. First one is the ships. So, it is made up of iron and metal which are denser than the water. The volume of the ship is much larger than the volume of the material by which it is made, and the empty space in the ships will contain the air, and the average density is very much less than the water. So, hence the ships will float in the small section under the water. So, this is how the ships are floating. Submarine, it is nothing but it sinks by taking water into its ballast tanks. Once submerged, upthrust is unchanged, but there is weight is increased. So, the compressed air is used to blow the water out of the ballast tanks. So, the ballast tanks is first filled with water, which will makes the average density of the submarine greater than the water. That times the submarine will be sinks, it will go under the water. But when the submarine surfaced, the compressed air is blown into the tanks, which will expel the water contained in the tank. Then the average density of the submarine will be less than the water, that makes the submarine to flow. So, balloons. A balloon filled with hydrogen or hot air weighs less than the weight of air it displaces. So, hydrogen balloons will go far away because of the weight loss. So, upward force on the balloon causes it to rise. Meteorological balloons carrying scientific instruments called radio sounds are sent into the upper atmosphere. So, it is in the space. So, the small radio transmitter sends signals back to earth which contains information about the temperature, pressure and humidity. They are tracked by the radar to give the data of the wind direction and the speed. Likewise, the balloons does not rise infinitely because as it goes up, it encounters air in low density. As a result, the weight of the displaced air becomes less when the weight of the air displaced becomes equal to the weight of the balloon. It does not experience any upthrust. Thus, it becomes stationary at that height. So, airships. An airship such as that in the figure has a plastic gas bag filled with non-flammable helium. So, a gas less dense than air. So, it is filled with the helium. It is powered by two car engines which drive swinging propellants to provide vertical thrust for takeoff and landing and horizontal thrust for forward motion. So, it can climb at about 700 meters per minute and curiously 80 kilometer per hour, and it can travel 1600 kilometer on just 550 liters of fuel. So, these airships are used for the aerial surveys, photography and advertising. Icebergs. Ice floats in water because it is slightly, that is less dense than the water. The medium in which it floats, but with the most part of the solid ice under water. So, next one is the floating or sinking of an object in a fluid. First of all, let us see the principle of the flotation. A body which floats in a liquid if the weight of the liquid displaced by the immersed portion of the body, that is equal to the weight of the body. So, this is the principle of the flotation. So, here you can see an experiment. When a body is immersed in a liquid, then two forces are acting on it. Weight W1 of the object acting vertically downwards direction and buoyant force W2 acting vertically upwards direction. So, W1 is greater than W2 because the weight of the objects is greater than the buoyancy force, then the objects will sink in the bottom. Therefore, if W1 is equal to W2, then the weight of the objects is equal to the buoyancy force, then the objects will float and the objects is at rest. In the third case, if W1 is lesser than W2, the weight of the object is less than the buoyancy force, then the objects will float partially and immersed in the liquid partially. So, what is density? The density of a substance is defined as its mass per unit volume. If the body of mass m and volume v and its density is, then density equal to mass m divided by volume v. The unit of density in CGS system is, the unit of density is g centimeter power minus 3, while in SI unit is kilogram meter power minus 3. So, the relative density or specific gravity is nothing but a substance is the ratio of the density of the substance to the density of the water at 4 degree Celsius. That is, relative density is equal to density of the substance divided by density of the water at 4 degree Celsius. So, otherwise it is called as mass of the substance divided by mass of equal volume of water at 4 degree Celsius. So, the relative density has no unit, it is just a number. The physical meaning of relative density is nothing but a substance is a number of times the given substance is heavier than the equal volume of water. Then when we say that the relative density of silver is 10.5, and it means silver is 10.5 times heavier than equal volume of the water. So, this is the physical meaning. So, here is a problem. A bottle weighs 30 gram and when empty 53.4 g when filled with liquid and 48 gram when filled with water. So, empty bottle contains 30 gram, filled with liquid it has 53.4 gram and it is filled with water is 48 gram. Now, we have to calculate the density of the liquid. The given density of water at 4 degrees Celsius is 1000 kilogram per meter cube. So, now we are going to find the density. So, they have given empty bottles weight is 30 gram, bottle with water they have given 53.4. So, for water they have given 48 gram. Bottle with liquid they have given 53.4 gram. So, to find the mass of liquid, 53.4 minus 30. So, mass of the liquid minus the empty can, which gives 2.34. Then the mass of water is 48 minus 30, 48 minus 30 which gives, so the mass of a liquid is, mass of the liquid is nothing but 53.4 minus 30 which gives 23.4 gram, whereas for water which is filled is 48 gram minus 30 which gives 18 gram. So, we have to find the relative density that is Rd. We have to divide the mass of liquid and water. Water is 18. So, we get 23.4 divided by 18, 1.3. 1.3. So, to know the density of the liquid, Rd, the relative density into density of water. Density of water which is nothing but 1.3 into 1000 which gives 1300 kg kilogram meter power minus 3. So, this is the relative density value 1.3 and the density of the liquid is nothing but 1300 kilogram meter minus cube.